Hey everyone, welcome back. Today in this video, we are going to see architecture of Hadoop, how exactly Hadoop works and how its architecture is. So let's see. First of all, Hadoop has basically three components, and those three components is first YARN, that is yet another resource manager. It works like an operating system. You know, the cluster has a lots of computer and managing the memory, disks and CPUs, it's a tough task. And that's why YARN comes in the picture. The second component is HDFS, that is Hadoop Distributed File System, and it is the component where your files or your big data is stored across the multiple nodes or multiple workers or the servers in a distributed format. So we can manage the data very easily. And the third component is MapReduce. And MapReduce is a processing framework or the processing engine comes with the Hadoop. So let's see the first component, that is YARN, and how it's structured. The yarn is again distributed in basically three parts. And what are the three parts of the yarn? Those are nothing but resource manager, node manager, and application master. We will see all the things in detail. But let's see what is the resource manager actually is. The resource manager. The resource manager is the master daemon responsible for managing the resources and scheduling the job across the cluster. Master daemon, it means a master process that works on a master node. It actually works to manage all the jobs that is provided by the user as a Hadoop application. Then the second thing is node manager. So as I told you, resource manager work on master node. In the same way, node manager work on the individual node, worker nodes. It usually uses to manage all the resources of the node. The node manager is a worker daemon that runs on each node in the cluster. And the third thing is application master. So what application master is? The application master is nothing but a specific for each application. Jobs or your workload is submitted to the application master, and it is responsible for negotiating with the resource manager for resources and working with the node manager to execute all your jobs by deploying the various containers for various tasks. Then the yarn component. Let's see how it works. Just imagine we have created an Hadoop cluster. Cluster is nothing but the bunch of computers that are connected across each other with the help of networking system. The computers or the servers, one server is master node or the master. It works under the master slave architecture. And the other are the worker nodes. You can see here worker 1, worker 2, 3 and 4. In the master node, resource manager is deployed as a container. Container is nothing but a executable part, or you can imagine it as a VM at the operating system level or one layer above the operating system. So resource manager is deployed on the master node, and on all other nodes the node manager is deployed to managing the resources of that specific node. Those resource manager is continuously in sync or in heartbeat with node managers to check their continuous states. When user submits an application to resource manager usually used to deploy a container called application master in any of the worker node, and that application master take cares how the application need to be run across the distributed nodes. The second component of Hadoop is HDFS, that is Hadoop Distributed File System, and it has basically two components, and those two components are nothing but name node and the data node. So let's see what exactly this is. Let's come into our Hadoop architecture. So this is the cluster of computer connected with each other with the help of the network. And here you can see the name node is the node that is solely responsible for managing the metadata of your distributed storage. And in every worker node, there is a data node that is used to process the data on that specific node. It can capture and process the data. So let's see, when user submits an application to the name node actually negotiates with other resources or other workers and check where it can store the data, and it will give the information. Then after that, your file or your distributed file is divided across the multiple files, and by default The blocks of the file are sized at 128 megabytes and the replication factor is 3. The replication factor is used to create the fault tolerance. When any worker node under the faulty situation, then your data can be recovered because it is stored across the node in the distributed and replicated formats. So your data is stored across the node with the help of data nodes and node manager. Name node actually captures your all metadata related to your every blocks. What is the block size? What is its starting address? On which worker node it is stored? From where to where we have to read, and after collecting, how we can combine the data to create your one gigantic file. So let's see how it connects. When user submits the collect application to it, then it will start and collect the data from distributed architecture and it will compile back to one single file and submit it to user. So the third component in the Hadoop architecture is Hadoop MapReduce. But why MapReduce? Actually, as I told you, MapReduce is nothing but a processing engine or data processing engine for the clustered computing. So just imagine we have a 100 terabyte file and that file is so humongous. It has a billions and billions of rows. Just imagine this file has 100 billion rows. So counting the rows of this file, this is the small program. And counting is not a big task. Still, it will take hours and days to count on a single machine. And if you try to imagine, if you have a biggest server available in the markets, if you go on AWS or Azure Cloud, then still at that place, you can get the servers with the RAM of like some terabytes and still it's a huge and you can't occupy a 100 terabyte file in a single machine. It is very hard to find such a machines, right? So if you start the program, it will like this. It will work like this. It will read the file, iterate over the file rows, and then it will count each row one by one and it will return. But it will take a humongous amount of time to process that. And that is very difficult in our fast database world. So the MapReduce framework or the MapReduce programming paradigm came into the picture and in which we have divided our file over the distributed storage like Hadoop or in modern era Azure ADLS or Amazon S3 or etc etc. So our file is distributed. So we can process the file on multiple machine at the same time. So what exactly it is? So map function will process parts of files at the same time across the machine and it will collate the data, and then after that with the help of reduce function it will capture all the data and sum up and give you the final count. So here the data is processed in parallel, that's why it's a very faster as compared to your traditional monolithic architecture. So let's see how MapReduce actually work and how it process the data. So just imagine this is your master node and your master node is connected with multiple worker nodes. In this scenario, your master node is connected with approximately 32 worker nodes. And on every node, one master node, you can see resource manager and name node is deployed. These are the two services. On every worker node, node manager and data node, these services are deployed. Okay. So just imagine your files is distributed across the distribution or across the multiple nodes or multiple workers. So in this scenario, how the data is processed? If you run the counting program, then your resource manager deploys one container on any one node that is called application master. Then application master checks with which worker node the data is available and everything, the metadata part. Then it will start creating the map function across the multiple nodes where the data is available. And that map function is nothing but a JVM process or the Java process, which will start reading the blocks of your files and counting them. And after that, it will create an array of counts. Okay. Then all map function after computation, they submit whole data to the application master. And after that, application master again deploys a reduce container on any one worker node or sometimes multiple worker node to reduce the data. And then it reduces the data in a specific format by counting all the list of the counts and summing up. And then it will sum up, it will submit it to application master and application master will submit it to you. and in this way MapReduce framework works. So this is all for this video. In the next video, we will see how Spark came into the picture, what are the drawbacks of all this Hadoop and MapReduce things. Till then, keep learning. We will see you in the next video.